In today's highly complex projects, many elements interact, often in surprising ways that cause the emergence of unanticipated behaviors. Taking project activities as an example, many of the most common models and views, such as Gantt charts, PERT charts, and work breakdown structures, do not provide sufficient richness to deal with these situations. These representations usually show only a minimal set of relationships among the elements, just enough to connect everything. However, if one actually asked those doing each activity in a project what information they need to do their work, they will usually list more than one item from more than one source. And they usually produce more than one result and send it to more than one recipient. Showing all this on a flowchart yields a mess of spaghetti and meatballs with many crossing lines, and users are quickly overwhelmed. In projects, information flow has critical implications. In manufacturing, two components cannot be assembled when one is not available. But in projects, most of the activity dependencies are based on information, and if this information is unavailable or incomplete, it is still possible to start the dependent activity based on assumptions instead. Of course, this increases the risk of rework, not only for the one activity, but for others that depend on it and also precede it at risk. Having the freedom to begin an activity without all of its necessary inputs can sometimes be helpful, but it can also lead to such problems, which often emerge later as unwelcome surprises. Actually, the most detrimental sources of rework can be pinpointed and avoided if an effort is made to understand the information flow among project activities. A modeling approach called the Dependency and Structure Modeling, or DSM, provides a way to manage these challenges. What is the DSM? It is a square matrix where the cells along the diagonal represent the project activities, arranged from initial upstream activities in the upper left to later downstream activities in the lower right, and the off-diagonal cells represent their relationships. For example, this DSM models 10 elements, labeled A to P. The marks in the off-diagonal cells show the dependencies, including those based on information flows. For instance, activity E provides outputs to activities B, F, and H, and it receives inputs from activities B, F, and H. Marks above the diagonal represent feedback from downstream activities to upstream ones. These relationships can also be seen in an equivalent node link diagram. However, when the number of elements and relationships increases, the node link diagram becomes increasingly challenging to visualize and manage. DSMs lend themselves to analyses like resequencing, which reorders the activities to minimize the instances of feedback and thereby reduce rework in the project. This resequencing corresponds to minimizing the number of assumptions that activities must make and maximizing the amount of work done with a solid foundation of good input. DSMs have been used to improve all kinds of complex projects in the aerospace, automotive, pharmaceutical, software, and other industries. Check out dsmweb.org for further information, or come to one of our conferences, the International DSM Conference. We are looking forward to get in touch with you.